Good day, everyone, and thank you for joining. I'm Oliver Cowan from the Endangered Wildlife Trust, and today I will be presenting on EWT's No-Go Map, an online tool for identifying the most irreplaceable sites for species conservation in South Africa. I will briefly provide the background to the No-Go Map and why we felt the need to create this tool, before describing exactly how we went about defining no-go areas. Following this, I will take a deeper dive into some of the tool's functionality before ending with several potential applied uses and an exciting new project on our horizon. The origin of the No-Go Map stems from the work we did on the Department of Forestry, Fisheries and the Environment's national web-based environmental screening tool. Many of you may be well acquainted with this tool, but please forgive me as I provide a brief overview for those unaware of it or those who might need their memories jogged a bit. The screening tool was created at the request of DFFE to generate a screening report which is required by law to accompany all environmental impact assessments, better known as EIAs. The tool contains spatial layers at a national scale for a broad range of environmental sensitivity themes, as shown on screen. Essentially, the screening tool and the associated guidelines were created to streamline the EIA process, standardize and remove some of the subjectivity previously included in EIAs, and allow applicants to identify upfront specific exclusions, restrictions, or exceptions that may apply to a particular site. Myself and colleagues from EWT, BirdLife South Africa, and SANBI worked together to curate the animal and plant species themes, and it's these two layers which inform the rest of the work I'll present on today. The animal and plant species themes contain spatial data for animal and plant species of conservation concern, that is, species listed as critically endangered, endangered or vulnerable, or range-restricted species listed nationally as critically rare or rare. Currently, the total number of taxa included in the screening tool amounts to some 460 animal species and over 4,600 plant species, with a breakdown per taxonomic group on screen. You may have noticed in the previous slides infographic the different colors for each taxa. This is linked directly to one final aspect of the screening tool worth mentioning, its use of sensitivity levels. For the animal and plant layers, 4 sensitivity ratings exist: very high, high, medium, and low. Sensitivity in this context refers to the likelihood of negative impacts from a proposed development and are informed by species occurrence records and habitat suitability modeling outputs. So in the example on screen for the animal layer, within the proposed development area in blue, one can see the areas of high sensitivity in red, as well as areas of medium sensitivity in orange, and also those areas in green where there's low sensitivity. I'm aware that this has been quite a brisk overview of the screening tool, so for anyone who wants to find out more, I encourage you to follow the link on the bottom right of the screen. Right, so let's move on to the actual no-go map itself now. The intended primary purpose of the tool is to inform the placement of proposed potentially detrimental developments in order to encourage early stage rejection or avoidance before EIA commencement. In this way, we can avoid unnecessary costs to the developer and the responding interested and affected parties, especially conservation agencies, and as a result, ultimately reduce irreversible loss of habitat to species on the edge of extinction. I'm aware that this may sound very akin to what the screening tool is set up to achieve, but please bear with me. Although the adoption of the screening tool has gone some way to address this, there has historically been some hesitancy to identify areas which are highly unsuitable for development. We wrestled somewhat with using the term no-go, as we don't want to appear to have adopted a fanatical anti-development stance. Indeed, we are cognizant that in a developing country such as South Africa, development is necessary and, in the case of renewable energy facilities, for instance, desired. Nevertheless, considering the size of the country, we don't believe small pockets of land essential for the survival of the most range-limited of species should be considered for development. The screening tool's highest level of sensitivity is labeled very high and does not explicitly highlight these areas from a development avoidance perspective. Furthermore, the screening tool data by necessity is hidden from users until the generation of the screening report. Therefore, there is no easy way of exploring the entire extent of a region and identifying areas best avoided. Our open access, user-friendly online app, on the other hand, allows for a rapid assessment of site sensitivity to inform the first stage of the mitigation hierarchy, that being avoidance. So how did we define the no-go areas? They are informed by the same underlying species data that we use to create the animal and plant theme of the screening tool, but only the most sensitive subset of these are used. First, we included only data from the very high or high sensitivity categories. Second, we kept only species which were red listed under IUCN's criteria B, C, and D. This ensures that the species included are facing threats directly related to habitat transformation and loss. Third, we calculated the total geographic area of the polygons in the screening tool layers and retained species which had a total of less than or equal to 25 square kilometers. These three filters therefore identified those species for which we have confirmed occurrence records from an extremely restricted area. There are a few caveats worth mentioning here. Firstly, users should not assume that an absence on a no-go report necessarily reflects a true absence in the field. For instance, species without a confirmed occurrence record since 2002 do not qualify on the screening tool for the high sensitivity rating, and therefore are not included on our map, even though they may still persist in the field. Secondly, there are certain species which are deemed sensitive to illegal trade and have had their identities masked on the screening tool. As an open access app, it would be reckless of us to include these species. Therefore, even though some sensitive species such as colophon beetles would qualify for the no-go map, they have been omitted. Nevertheless, I guess you could say worrying number of species are present in our tool, with a taxonomic breakdown shown on screen now. So now you know why the tool was created and what is included in it. Let's show you some of its functionality. The default landing page takes you to the nationwide extent with all no-go areas already mapped. One can either zoom in with your mouse or touchpad or using the buttons at the top left of your screen. Just below is an option to reset the view to the original. And here in the top right-hand corner, the user can choose between 3 base maps and toggle on or off 4 layers: the no-go areas themselves, the terrestrial protected areas of South Africa, and farm portions and earths which intersect with no-go areas. Above the scale bar in the bottom left is an info button which takes you to a web page with background information on the tool and a video tutorial on how to use it. The final buttons on the landing page allow the user to draw their own polygons or rectangles, edit their polygons or rectangles, or delete them entirely. Here I've zoomed into the Western Cape interior and created a polygon around the village of McGregor. At this resolution, one can hover over individual no-go areas and the identity of the species pops up. Also, once you've drawn a shape, an option appears on the screen to allow the user to download the shape as a shapefile and to reset and clear the map if required. By clicking on the interactive map option on the top left of screen, one opens up a suite of options with which to navigate the map further. Firstly, one can upload a shape or KML file from your own computer and plot it onto the map. Secondly, one can search for no-go areas using the 21-digit Surveyor General Code. Thirdly, one can enter the coordinates of a particular point, add the point to the map and zoom to it. And fourthly, one can plot the entire extent of an individual species either by selecting it from a drop-down list or from typing it into the species bar. Here I've selected the rough moss frog, Arthroptera grygosa, and clicked Plot Species. The map viewer has zoomed into its entire extent, and at the same time an option to toggle the species on and off has appeared at the top right of the screen, and the selected species has been added to the legend in the bottom right of the screen. Here I've changed the base map to satellite imagery to get a better understanding of the surrounding landscape, and toggled on the Protected Areas button to assess whether the species is represented within a protected area. We return the extent now to the village of McGregor and my previously created polygon. Another useful function can be found under the Data Table Outputs tab. By clicking on the tab, one can inspect and download a list of the species that intersect with the spatial input chosen by the user. In this case, I created the polygon myself, and thus I navigate to the hand-drawn polygon tab, and it shows the species present within my polygon. With an option to download the species data to my machine, I can also expand the Property tab to get a downloadable list of the properties intersected with the no-go area. Aside from the primary objective of the map, the data can also be used for a number of applied uses. On screen now is the result of a simple hotspot analysis showing where in the country these no-go areas are most dense. One can also overlay all the no-go areas over the current protected area database and isolate those without formal protection. Then, with a bit of GIS modeling, one could set parameters to identify potential focal cluster areas which can inform potential protected area expansion. In this example, I've set a buffer of 250 meters around protected areas. No-go areas must be within 20 kilometers of one another to be considered part of the same cluster, and there needs to be a minimum of 20 no-go areas to form a cluster. Another potential example would be to assess whether a severely range-limited species is represented within critical biodiversity areas. CBAs are important biodiversity planning tools and take into account a variety of information on habitat quality and importance to ecosystem functionality. However, in this case, one can see that much of the known habitat for Arthroptera rugosa, the critically endangered rough moss frog, falls outside of designated CBAs and nature reserves. Information such as this has actually guided EWT's Threatened Amphibian Program to prioritizing the protection of the remaining habitat through stewardship or conservation servitude options. The idea to take the species data out from behind the walls, so to speak, of the screening tool has also led to an exciting new project that I'm going to tease to you now. That is the creation of a tool to inform land use decision-making with regards to species of conservation concern. We've been working hard with Sanby on this tool, and it should be rolled out onto their BGIS website early next year. The tool will, of course, be open access and easy to use, allowing users to explore specific regions of interest or on a species-by-species basis. Aside from distribution data on all species present in the screening tool currently, it also includes near-threatened species. This will add over 1,200 additional species into the tool's database. In addition to the layers included in the screening tool, our new tool includes the actual species distribution modeling outputs where available. Thus, the user can visualize and explore for themselves the habitat suitability and model uncertainty for each species. Finally, we are also looking to incorporate into the tool distribution modeling under different climate change scenarios for those species which are likely to be impacted by the inevitable changes we will see in the coming decades. So this has been a very brief introduction of our new tool, something to whet the appetite, if you will, but look out for more details as we will roll it out to the public in 2023. Although we are very excited about the LUDS SEC tool, let's not get completely sidetracked from the no-go map, a tool itself we consider valuable and informative towards conserving our most threatened species. My time today has come to an end, but why not explore the tool yourself? The link is on screen, or just Google EWT no-go. And remember, there are resources available to guide you. Well, that's it from me today. I'd like to thank Dominic Henry, whose role has been integral in the development of these tools, and my colleague Ian Little. Finally, thank you for joining me today. Cheers.